Hello and welcome to my video. I hope you liked the demo project in this post and that you were able to understand each of the steps. I didn't go into details with all of the math because in SAID we haven't really seen anything like that, so I didn't really see the point on showing all of the math details. But I made sure to talk about all the concepts, so it'll be easier to understand. So it's not just a bunch of um, meaningless graphs and stuff. So in this video, we're gonna do a quick recap on what we saw. So we're gonna review how to explore audio data. We're going to recap on feature extraction. Also, we're gonna do more feature extraction in different genres, and just to see the variety feature values. We're also going to see more of the exploratory data analysis, and I'll show you the classification of genres. Well, first of all, I'm going to show you the dataset. So this dataset contains two folders and two of these CSV files. So in the first folder called Genres Original, we have 10 folders. Each of the folders contains 100 files, audio files of 30 seconds each. So that's a lot of data. And the images are original. We have the same audio files, but they're not in audio. They're in images. So here we have a mel spectrogram. So yeah, all of the same songs, same data, but as images, because that's how neural networks kind of work. We're not going to be using these images original in this project though. We also have these files. They have all the features, 60 features of them, of all of the files. So there's a length and there's some of the features that we saw in the project. So that's kind of how the written data looks like. And this file is the same file, but instead of all the files, instead of all of the songs being 30 seconds, all of the data is split into 3 seconds. So it makes it 10 times, like it gives us 10 times more data, which when you're working with data, it's the more the better. So let's get started. I'm not going to take a lot of time doing this because we already saw all of the code, but this is all of the libraries we used. Here we're loading the data. Oops. We're loading it. This is all the genres because we're listing them. Here we import this file. How you want it to be. So yeah, that's the one. I wanted to explore the audio data. The sound, I already explained what it was, and all of these means. This is the sound wave for Hit Me Baby One More Time, or that snippet of the song at least. And then we get the time frequency of the audio file, and then we get the Fourier transform for that same song. We have a spectrogram, and over here we have the Mel spectrogram. As you can see, it will have different colors, but it should be the same. Yeah, it looks the same with different colors. Then we get the number of zero crossings. We get the components of harmonics and percussive. They're divided by color, so the harmonics are the pink ones, and the percussive, percussive, sorry, are the the other way around. Sorry, the harmonics are the green ones, and the percussives are the pink ones, or magenta. We get the tempo and the centroids and the shape of these centroids. We get the frame and time frame. We get the spectral roll-off. And then here we get the Mel frequency, spectral coefficient shape, and spectrogram. This is a different spectrogram, or a different graph. Then we have the chroma features. And now, like after this, we've already extracted all of the audio features for Hit Me Baby One More Time. So now we're gonna do exploratory data analysis. For this, we load these features. This is how it looks like, but we already saw that. We're getting the correlation matrix, and then we use that and put it in the correlation heat map. Now we got the tempo, beats per minute box plot. As we can see, this all of the genres have different beats per minute, like averages. We have the principal components on genres here, all of the different genres on the graph. And now we start loading the data to classify it. Here it is. Looks the same, but this is actually 10 times more. But we're only showing the first few. We have to get data, normalize it, and here I have a function that I define to test accuracy of a bunch of different models. So we have the naive base, all of these different models, and although this one, the one that I used, the K nearest neighbor, wasn't the most accurate, it was the one that I was more acquainted with. So this is how it looks like in the end. So over here I loaded another file, a different file, so we can explore all of the features from that one as well.
Shut your trap, come back, get back, that's the part of success.
So this is how this song looks in sound waves. This is how it looks. All the harmonics and percussive. So you can see that that's a big difference from Britney over here. Oh, I didn't put that one. Oh well. The Fourier transform, and that's Snoop Dogg song. The spectrogram and the Mel spectrogram. Let's see how the one from here looks like. 33. So that's how it looks like in the data set, and this is the one we have, so they look the same except for the colors. We have the tempo and all of these fun features. It looks way different than with the first song. And the chromogram shape looks way different. And in here we're trying this rock song. The girl I met last night. It sounds 80s and it sounds nice. So we have all of the sounds, all of the different features. It looks way different as well. As you can see, the percussive is way higher than this one, stronger. We have the Fourier transform, as you can see, way different. This is the spectrogram, and this is a male spectrogram. Let's see how it looks. Yeah, they look exactly the same except for the colors. I hope you liked my video. Yeah, I hope you liked it.